And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today it's part 2 of our Luxman SQ202 repair. Last week we left it waiting for some parts. Let's get back into it. Right, it's a few days later. I've had some bits turned up. We've got some nice mica washers. So I've rebuilt this amplifier module, so that's both of those now done. So I'm just going to put those to one side for a moment and turn our attention to the main chassis. A little zoom out a little. There we go. Because these are the capacitors I'm not very happy about. These three here and these on this sub panel as well. These two 220 mic 100 volt capacitors here. I did check stock. I was out. I have ordered them, but they're on back order everywhere. So hopefully they will be here very shortly. And in fact, I'm not sure whether they're leaking or not. Anyway, we shall replace them at a matter of course. Then there's these three down here. Now, according to the schematics, these are supposed to be about 6,800, I think they were, each. Well, that's a 10, that's a 12, that's a 12. Yeah. So I've got two new 10s to go in there, and these are the same size. So that's nice and convenient. And as for that one, that's rated 100 volts. I'm just going to stop here and go and have a look at the schematic, because I think this is an RS one from 1983. So I think somebody's been at it before and just fitted what they had. But I'm just going to check on the voltage rating of that before I put something in that's not going to cut the mustard. Well, I'm a little unsure on my schematic because it's not for exactly the same model. So about the only way I'm going to do this and know it's not a 100 volt component is to just hook a meter. So I've got my meter hooked straight across that capacitor. Although we haven't got the power amps in, the voltage might rise a little bit because it's off load. But yeah, I thought the sensible thing to do would be to wind it up on the variac. So mains power is on. We've got 0 volts on there at the minute, but I've got 0 volts on the variac. So I'm just going to turn that up and see where we get to. About 4 volts, that's not very much, is it? 5, and we're at 100. Right, that's full chat at 200 volts, and I've got 12 volts. 12 on a 100 volt capacitor. I've still got the fuse out for that power amp where it failed and took the fuse out. Let's put that back in just in case it's on that rail. Right, bear with me one moment. Well, that fuse wasn't doing much at all, and in fact that is in fact the speaker fuse, so it makes no difference being as the output modules aren't in. But in digging in my file of schematics, I did actually find I do have the schematic for a 202. I was previously working from a 507, which is very, very similar. But that capacitor, that one there, that somebody's replaced it with 10,000 mic at 63 volts, it's on the 12 volt rail. And well, 11 volts, I think it is. It's used to run the lamps, which illuminate the front panel and the switching. And I think the 11 volts does go off somewhere else and do something else. But 1,000 mic to 10,000 at almost 6 times the working voltage seems a little bit overkill, don't you think? And it's been in there forever. So yeah, the original smoothing, you remember I said it was, I thought it was 6,800 microfarad, 6,800 mic. It turns out it was actually 3,300. So I can see, I sort of understand somebody wanting to go for the main plus and minus 48 volt rails, bringing the smoothing up a bit on there. But that 12 volt thing, that's just madness, isn't it, really? So yeah, the 12 volt rail that we're seeing on there, 12.47 off load, yeah, it's about right, really. So yeah, let's set about putting this thing back to something approaching a decent specification, I think. Right, I have procured some spare parts, and I have decided that this capacitor here that somebody's put 10,000 microfarads in is just overkill. Is it going to do any harm, it being that large? The problem I've got is how much stress it's going to put on inrush, on the winding that's not really designed to cope with it inside the transformer. It's the only fear I really have. But just 10,000 mic, I mean, that's 1,000 times bigger than the original. So yeah, I don't think that's... I think we're going to downsize it. Anyway, the other two, let's get them all out, I think. So I've got the torque-free wow stick here. Let's just start that one off. That's that loosened off. They're just on ordinary clamps in there. Not particularly tight, actually. How am I going to get at that one there? Oh, I've left my socket behind. That might be interesting. Where is the flexi drive thing in the iFixit kit? Where is the iFixit kit? That's over there. See if we can't get on it just about with that, I think. What am I doing? That's it. See if I can't just weed. Where did that go? Oh, hey. Failure to lock it in position. That's it, we're locked in position this time. If I can just get that on the nut, I can. Just give it a twist. Hopefully it'll come out. Yeah, we're loose. Okay, so I think what I'm going to do is sensibly rate that capacitor. I mean, it was 1,000 mic originally. Maybe we put 2 in there. So I've actually got a 2,200, but clearly it's much smaller than 10,000 that's in there. So I need to 3D print a little adapter ring to go on there. Yeah, right. So I think the first one to do is this middle one here. Let's rearrange things a little bit. Make it easier for ourselves. Make it easier for you lot to see what I'm doing. So here are the 2 larger capacitors that we're going to change. I suspect they're probably all right, but I don't know how long they've been in there, and I don't like what else has been done to parts of this amplifier, so let's just evict them, replace with new, and then we're good for a few years yet. First one is out. Got a nice new one that's going in. Could just do with tightening that one up. Just to hold it in position before gravity has its effect. I need another hand. Try to hold the end of the screw. There we go. I don't want you to hear that. That one's actually rattling. It's suboptimal. Another brand new one. Okay. Right, let's just make sure they're sort of torqued up a little bit. Right, that one's done up. Oh, they're not going to fall out, are they? Right, the next thing we need to do is 3D print a spacer to hold our smaller capacitor in where that bigger one has been bodged in. So, yeah, quick trip over to Tinkercad, make something up and get it printed. Right, I've set the 3D printer going, and in the meantime we can get on with these things here. Incidentally, I have just removed the capacitor from there, which I erroneously told you was 10,000 mic. And you know, it's not, it is 1,000 mic. But it's 100 volts rated on the 12 volt rail. I think this has had quite an easy life in the last 30 odd years. But we're changing it anyway. So, yeah, there we are. Right. So this sort of power supply board here, I'm going to have to sort of hinge forward, I think. It's connected by a lot of wiring on the other side, which I don't really want to disturb. And this might be a chance for me to try out my new JS screwdrivers. I have never owned a set of JS screwdrivers, and I thought that was a mistake. So I've been out and I've purchased myself some. Oh, they're nicely magnetic as well. That's good. I am going to put that screw there carefully. They could do a bit longer, but the choice I had was almost non-existent. These are US Pro, which sort of made me laugh a bit, but that was all I could find on eBay. Right, am I going to be able to get at things on the back of here? Not really. This is going to be a struggle. Let me just flip this up there and see what's holding us back there. Maybe if I take this insulating bracket off here, it may allow me a bit more movement. It must be said, this screwdriver sucks the screws out of the board. Just a little sort of spacer thing. Right. And you can see all this wiring attached here. If I could possibly get away with not disturbing this, I will, because I don't want that headache. Well, it's going to be a struggle, isn't it? But I think I can get away with that. Right, one thing I am going to do before I go any further is mark the polarity up. If I can actually see it. Yep, negatives are towards the middle, which would make sense because those two are commoned up and it'll be a split rail supply. So, yeah. Right, let's remove these top ones first. Yeah, these are the original parts. You can tell because they are glued in. And it reeks, I have to say. I think they are well on their way. Yeah, they've seen better days. Right, I'm going to leave those two out while I concentrate on the next ones down. Let's see if that camera is ever going to focus. I have trouble with that camera. It doesn't always like to focus. But yeah, you can see if I leave those two out, I can then get at these two underneath. And again, I'm just going to have a little look at the polarity. They seem to be a little bit different, so... Oh! And also we have a resistor that's burned up just in there. Okay. This is going to make life a little more difficult, isn't it? Yeah. I think I'm going to go and have a cup of tea and think about this. I just had a look at that resistor that I think is a little bit scorched on the schematic. Schematic tells me it's 1.2k, and it does in fact measure 1.2k. It's just been a little bit warm in its life, so he can stay for the time being. I have removed the fixed sort of wiring from the bottom of this board, so I've given myself a little bit more clearance there now. So hopefully I can just get in there and finish removing and replacing these capacitors. Yeah, and we can see a little bit of electrolyte leaking from that fella. Negative in the middle again, unsurprisingly. And again, electrolyte leaking for that one. Good, it's all worth doing in the end. Now, I do need to just clean some of this solder off this board. So let's just do that with the old desoldering gun. It's looking pretty clean now. Right. So we need 2 lots 47 mic. Right, that's an epic little job. We'll get those screws back in there. Do that straight away. I think I might need the next GAS screwdriver down for this job, really. The trouble is, that's shorter again, but we'll have a little go. And just got a wiring to put right there. I will consult my TV, my photograph. Okay, well the 3D printer's finished, so I'm just going to go and get that 3D print. We'll fit that 2.2 1000 mic in there. I'm going to fit a 2200 because upgrades. And yeah, we're then ready to reassemble the power amps back in and set the bias and offset. So that'll be good fun. There, got there in the end. Looks a bit daft really, doesn't it? But such is the advancement of modern electronics. Stuff doesn't get any bigger. Right. Set this one in here. Ah, fits a treat as well. That's super. Let's just nip that up. Lovely. I just want to make some loops on the top of this capacitor because obviously the original one had tags on it. We don't have that anymore, so if I just loop the wires over and then solder that up, it'll be just the job. There we go. Right, fit the power amps and set the bias. Right, well this was all offending me. I was going to do the power amps, but this sort of caught my eye and offended me. So what I've done, just to straighten this section out, I don't think you see that. No, you can't, you're not on the camera. There we go, you can see on camera 2 up there. That's the wrong side. Oh, we'll get there in a minute. Let me angle the camera up. What do you reckon? There we go. You can see that's all bent there, and it's really quite horrible. So just remove the mains fuse from in there. And I'm just going to try and just tweak this back into some sort of shape, really. You can tell it's been dropped. There we are. That's coming back into shape. It's looking a lot straighter now. I did take these screws out of the end there as well, just to give me a bit more clearance in there. Right. It was just offending me. I had to do it. Right. Got a few things set up, ready to go. I'll just talk you through what we got. I have one power amplifier plugged in. It just so happens to be it's the right hand one. Across the output from the right hand speakers here, we've got this fluke meter set to millivolts, and across the 2 emitter resistors on the power amplifier I have this Metra hit, again measuring millivolts. So we have 2 pots on the board. One will adjust the DC offset. I want to get that as low as possible, really, and the other one, that's DC offset. This one is bias, and yeah, we need bias to be set to a specific level, and this is a multi-level task. We have to repeat the process with a couple of different conditions. So I'm just going to power on, and initially I want about 20 millivolts across our resistors. As you can see, I've got about 10 at the moment, and we've got that's decreasing nicely, actually, so we might be somewhere in the ballpark. It does take a little while to settle, and this is very common. So I'm just going to, well, the bias is creeping up on its own, so let's wait a couple of minutes just for that to sort of steady itself. We're at 12.913 and it's rising. DC offset has gone slightly negative, so we could move that if we wished. Beauty of this is we now have multi-turn pots in here, which will make life a lot easier. I did take some time just to center these pots before I switched on. There we go, we're down to 2 millivolts there. That's almost acceptable, really. And we're at 15.9 here. Now, at this point, I'm going to go away for a quarter of an hour, make a cup of tea and come back just to let this thing settle. As it does warm up, things will move about. So, but that's all part of the fun and games. Right, I'll see you after I've had a quick brew. Right, well, it's been about a quarter of an hour. And as you can see, our bias has risen considerably. Our DC offset is still acceptable. So I'm just going to back that back down to the wrong way. Back that back down to about 20 millivolts. This heatsink is a little bit warm, as we'd sort of expect. .2, close enough, and we've got 3.4 millivolts DC offset. Let's just bring that down. There we are. Okay, now the next trick is to connect a speaker. We actually want to increase that bias current now until we've got about 50 millivolts across our emitter resistor. Right, I've got a workshop speaker that will do nicely. Okay, I will need to measure the voltage again in a minute. So powering back on, I've got a pop in the speaker, so that's good. By the way, you'll see this is reading negative, by the way, here, but it's just the lead orientation. We're not reading reference to earth or anything, it is just the voltage across those. As you can see, our bias has fallen a little bit. So I'm going to take that back up to around 50. Just have a little look at our DC offset. We shouldn't have much there. A little more than I'd like. So about 10 millivolts. I wants to be near to 0 as we can get it. With this pot, by the way, on the speaker polarity, you will know it'll swing. It does swing both positive and negative. It'll also respond, by the way, to noise. So if there's something goes on and off in the workshop, sometimes you can find that does that. And again, now we wait for a quarter of an hour. You can see that's creeping up already because the temperature of the transistors is increasing. Back it back down again now. And we'll just leave that again to settle in. Right, we have been on another quarter of an hour. We've crept up just a little shade there to 53, so I'm just going to adjust that back down now. The heatsink is nicely warm. I'm not going to burn myself on it by any means, but yeah, it's warm. Just want that set at 50. 50.4, 3, 2, 1, 50. 49.9. It is drifting about a bit. You see this little green component here? That little thing, that's a three-legged... There are 3 diodes in there, and they're actually using that as a sort of temperature compensation. Often you see them bolted against the heatsink of an amplifier, but Luxman didn't feel the need for that. 50.07, that's good enough. Let's just have a little check of that DC offset. Get that as near as to 0 as damn it. We're at -4. Next to nothing. That'll do. Right. I suppose one last test would be to see if it's making some pleasant sounds. By the way, when you do this, I always set the volume control to 0 and select an input that I'm not using. But I'm actually selected aux 3, which is that one there. Let's bring the old MP3 player up. Still fighting strong after all these years. As you play a bit of music, by the way, we'll see the current obviously change through the emitter resistors, so this will go a bit haywire, I should imagine. But there we go. Excellent. So now all I've got to do, put that one back in, set the other one up in exactly the same manner. I'm going to do that off camera. You don't need to see it twice, do you? Well, the amplifier is playing really well. I've got 3 niggles left, well 2 because I've already done one off camera, and that was the auxiliary 2 indicator light, which had an open circuit bulb, which I have changed. The tape monitor switch here on the front doesn't always latch. If you're gentle with it, latches every time. And this has been another victim of whatever damage has been done to this amplifier, because the thing's actually bent. Let me zoom in a camera there for you. If it'll focus. Go on, focus. You know you want to. Maybe it won't focus. Oh, there we go. So yeah, if I just find the thing, it's here. There it is. You can see it's been bent out of shape here. And the front of it is all buckled as well. So yeah, this amplifier has been in the wars over the years. But there's nothing much I can do with it. It wants replacing ideally. But we don't have one. And the chances of ever finding one are about 1,000,000 to 1. So yeah, not ideal, but there we are. If you're gentle with it, it does work every time. So I think we'll have to live with that. The other problem I've got is these switches on the front. You see on this camera here. These ones here are all at an angle. And it's because of this board here. It's not sitting level. And you can see it's supposed to be a groove there that holds these 2 boards. But they don't. So I'm thinking I might just 3D print a little piece just to hold that in the right position, so all these switches will be much happier. You can see perfectly aligned there when they're on this slot on the board. Or the other thing I could do, I suppose, is make 2 little pieces that just hold it correctly in the slot. Be a bit of a fiddle-faddle to fit. I wonder if that's actually bent. Is that our problem? It is. That's bent out of shape. The whole thing has had a whack in its life, hasn't it? Well, we know that. So all I've got to do is persuade that plate to come over a little and hold our board straight. It's there. Yeah. If only there was a method I could take that out and bend it. Trouble is, I'm going to have to disassemble the whole front panel to do that. Oh, hang on, it's this board. It doesn't fit either board. And that's interesting, because this one's held in place with a little piece of sort of close cell foam. I wonder if this had that in it originally, and now it doesn't. Maybe that one was held in because this board should be over a bit. Trouble is, it's pushing against that sub panel then. This needs a bit of advanced engineering. I think I make a piece up, not out of foam, but out of a 3D print, and bond that into position, just like on this side. Because yeah, that plate doesn't meet either board. How unusual. Obviously, somebody at Luxman dropped the ball a little bit. Yeah, so I want a little U-shaped piece, or maybe 2 little U-shaped pieces, and some stick. Get it in the right place. Let's have a think on a 3D print. Right, while I was waiting for the 3D printer, I battered the bottom of the cover plate back into shape, so that's good. And I've 3D printed a couple of these little things. You see that there? Just a little sort of C-shaped piece. And what I'm going to attempt to do is drop it in the back of there, push that into position, and then glue it. So that could be exciting. Rip it in a pair of pliers and try and feed it around the back of the PCB. You'll see the idea in a second, I think. So just get it in like that. Drop it into position. There we go. So now I need to hold that in place and then glue that to both panels, I think. How am I going to hold that into place? Need a little clamp. I wonder if a crocodile clip will do. One way to find out. Might not be long enough. Just pull the cover off it. That just about perfect, I think. Right, let's find some suitable glue. We'll try super glue. Not oft known for its ability to stick to metal, but let's try it. Yeah, that looks okay. Let's get a bit of activator on it and leave it to set. Where is the activator? I had a tidy up of the aerosols the other day. Fatal. There we go. Right, let's leave that to cure and think about putting one on the other end as well, I think. But we'll see if that one does the job first. Certainly the alignment of the switches does look a lot better on the front panel now, so that's first rate. Right, pop back in a bit. There you have it, the Luxman SQ202, once blown up, now sounding absolutely wonderful, I must say. Very good. I'm sure my microphone's not doing it justice, but anyway, there you go. Justin is adamant that he needs the tape monitor switch replaced at some stage, so if you know where we can get one, drop us a line, leave a comment down below. Be very grateful. Maybe you've got one you want to part with, but there we go. But for now, it's working okay and everything's good. I'm going to leave it on now to soak test it for a couple of hours just to make sure everything's sweet, and then Justin can come and pick it up. Right, thank you very much for watching. Leave a comment, click like, subscribe, share, all that rubbish. Buy me a coffee if you want, there's a link down below. And I'll see you next week here on Doz's Television Workshop. Cheers now, bye.
Thank you.